Good morning. Today we are going to go over lesson 4.8, which deals with lines in the coordinate plane and equations of lines. So from your investigation yesterday, you would have hopefully come across the conclusion that the two lines, the line 1 and line 2, did turn out to be parallel. And you notice that they both had a 3 in front of their x, which is an important fact. That's because they were in slope-intercept form, which is y equals mx plus b, where m is the slope. So for parallel lines, if the slopes match, the lines are parallel or possibly coinciding. Point-slope form is just an alternate form of an equation of a line, which comes in handy to use when you're given the slope and a point as opposed to slope and the intercept. The equation of a vertical line, so that's a line that's straight up and down, is x equals a, where a is the x-intercept, because with a vertical line, you only really know where that line crosses the x-axis. On the other side of that, the equation of a horizontal line, so a flat line, is y equals b, where b is the y-intercept, because again, for a horizontal line, you only really know where that line crosses the y-axis. Remember, the slope of a vertical line is undefined, whereas the slope of a horizontal line is 0. So what we're going to do is practice finding the slope and then using slope-intercept form as well as point-slope form. So we are given the same 2 points in this problem. So the first thing that we want to do with both of our points is find m, the slope. So remember that m is equal to the changes in the y values. So we can say 5 minus 4, and then we divide that by the changes in the x value. So we have to go in the same order. So we did 5 minus 4. So we're going to do 0 minus 2. So this simplifies to 1 in the numerator, negative 2 in the denominator, which 1 over negative 2 is the same thing as negative 1/2. So this is our m value. The next thing we want to know for slope-intercept form is the intercept, and that's the y-intercept. That is a point that is of the form 0 for the x value and something for the y value. And in this case, we are given 0, 5. So now we have our b value. B is 5, and m we already found was negative 1/2. So with that, we can now write the equation of our line in slope-intercept form, because we have y equals m, which is our slope, so negative 1/2 times x, and then plus our b value, which was 5. Now we should get the same result in the second step here of this problem, but we're just going to approach this point-slope form, so approach finding this equation from a little bit of a different angle. Now step 1 would be to find the slope. Now we don't need to repeat our steps that we did in part 1, so it'll suffice to say that given these same 2 points, m is equal to negative 1/2. So we have our m value. That was negative 1/2. And then y1 and x1, those are simply just a point. We can choose either point to work with. My advice is to typically work with one of the points that does have a 0 in it, because that might eliminate an extra step of work. So what we have is y minus the y value of our point that we chose to work with is equal to m, which is our slope, negative 1/2, and then in parentheses, times x minus the x value of the point that we chose to work with. So going one step at a time here, simplifying, we have y minus 5 is equal to, well, x minus 0 is just simply x, so we have 1/2 times x. Now, we do want to make this equation in the form y equals and the rest of it, so we are going to add 5 to both sides. And so when we draw our line, what that results in is y is equal to negative 1/2 x plus 5. So no matter what approach we took, we did get the same result. We got the same equation, that y equals negative 1/2 x plus 5. The next task would be to graph this line. So again, this is actually in slope-intercept form. That means this is our slope right here, our m value. That tells us the steepness. This is rise over run. And remember that 5, this is our y-intercept. So when you have the equation of a line given to you in slope-intercept form, it actually becomes relatively simple to graph. The first thing you want to do is start with your y-intercept. That's going to be your first point. That is where you put a point on the y-axis, so it's plus 5. So we're going to put our first point over here at 1, 2, 3, 4, 5. Positive 5. From this point, we can find our next point by using our slope. So our slope is rise over run. So it says negative 1 over 2. So instead of rising, we're actually going to fall, because that's what the negative means. The negative means fall 1 and run 2. So that means our second point is going to be right here. All you need is 2 points to sketch a line. So once you have your 2 points, you can put a straight edge or a piece of paper, the edge of a binder, against those 2 points and strike yourself a straight line. And this is the equation of your line. A quick check, your slope in your original equation was negative. That means your line should fall if you read from left to right, in which case this does. Also, the line should cross the y-axis at positive 5, and it does. So this would be a graph of our line. The last thing we want to talk about is the importance of slope when you just look at the equation of a line. So you can tell a lot of things. You can tell if lines are parallel, if they coincide, which means it's actually the same line, if they intersect, and you can also tell if they intersect at a 90-degree angle, which would make them perpendicular. So these symbols read parallel, perpendicular, coinciding, which means the same line, or intersecting, which you can also tell if it intersects again at 90 degrees, which would in fact make them perpendicular. So the important thing about parallel lines, as we've discussed before, is that they do have the same slope. So when you have them in slope-intercept form, the number in front of your x is the same. An important distinction is that for them to be two different lines that just simply are parallels, they have to have the same slope, but they do have to have different y-intercepts. That's what makes them a different line. Whereas if they had the same slope and the same y-intercepts, the same slopes of 2 and same interslopes of -4 and -4, this is the exact same line. You would not be able to, if you graph them, you would not be able to distinguish from one line to the other. So this would be coinciding lines. Now, intersecting lines are going to be two lines that have different slopes. They could or could not have the same or different y-intercepts. That's not an important detail. What is an important detail is the slope. So if the slopes are different, not only do they intersect, but you can determine if they are perpendicular. If they are perpendicular, the slopes are actually opposite reciprocals, or if you want to think of the word refliprical. So for example, if one slope was 2, the opposite, it has to be the opposite sign, so if it's positive 2, we now think negative, and it's the reciprocal, so the flip of 2, which is 1/2. Or as another example, if our slope was 1/3, the opposite reciprocal, so the slope of the perpendicular line would be the opposite sign, so negative, and you would flip to 3/1, or just 3. Now, if they're not opposite reciprocals, or if they're just truly random numbers, that means they simply intersect, but they're not going to intersect at a 90-degree angle. So looking at this first example, first thing we look at are our slopes. So 5 matches 5. So at this point, we're either parallel or coinciding. Because our y-intercepts are different, we know that these lines are parallel. Looking at our second line, 1.3x plus 1, 1.3x plus 1, our slopes match, our y-intercepts match. This means these are the exact same lines. So these are coinciding lines, exact same line. Looking at our third example here, first thing we're going to look at is our slopes. So 5 and negative 1/5. So first of all, these are different. So we know that these are intersecting lines. But a follow-up question could be, are they perpendicular? A quick check, if you can't tell by looking at them if they are opposite reciprocals, is to multiply the values together. So 5 times negative 1/5. If you get a result of negative 1, that means they are opposite reciprocals. So 5 times negative 1 is negative 5 divided by 5. And when you simplify this, you do get negative 1. If you do not get negative 1, they are not perpendicular. If you get anything but negative 1, they are simply intersecting. We did get negative 1. That means these two lines are not only intersecting, but they are perpendicular as well.